Hi, I'm Steph Strickland with GeekWire Studios, and I'm your host for Does Compute, the podcast where we delve into the latest innovations in computer science with the help of experts from Carnegie Mellon University's School of Computer Science. I want to introduce you right now to Vivian Shen, a doctoral student in the Robotics Institute doing research into haptics with the Future Interfaces Group, which is an interdisciplinary research lab within the Human Computer Interaction Institute at CMU. Vivian's research centers on fine-grained haptic immersion in AR and VR. How are you doing today, Vivian?
I'm good. Thanks for having me here, Steph.
Glad you've made the time for us. I want to start a little bit by finding out what drew you into the field, this intersection of touch and technology.
So I've always been doing sort of robotics and embedded systems since high school. My high school was lucky enough to have a robotics team, and that's where I first got exposed. And sort of the first feeling of seeing something that I built move, that was an incredible feeling for me. I just was really exciting. I'd never experienced that. And so I was really interested in technology and robotics. But really, what brought me into this area of like touch and human computer interaction is that I've built various devices, but my favorite devices that I've built were ones where I could get a real reaction out of people. Like when people smiled because they used my device, or when people like were like, whoa, or like had some sort of reaction. I found that very exciting. And there's a lot of technology that we're building that's very important, but that doesn't interact with humans. If you think of like automotive manufacturing robots or those kind of stuff, very important for our society, but I personally like just really like working on things that people get to use and touch. And so that brought me into human computer interaction. And I think that from my experience, haptic devices are some of the devices that get the most sort of reaction out of people because it's really physical. People feel something and they often want to react when they feel something physically. And so that's sort of how I got started in haptics and what drew me to it.
I am 100% having my daughter watch this interview because she has just joined her robotics team, and
Okay.
it's been a game changer for her to watch her world broaden when she sees the robot that she wired move and the sort of ingenuity and creativity of these kids. So I love hearing about that. I want to talk a little more about haptics specifically because you said something that struck me. When I'm old enough to remember the games we used to play like Pong and these very sort of 2D flat games that blew our minds because of what our imagination could do in the moment. And
Mhm.
now computer graphics are the way we interact with our vision within a system is fairly robust. Our expectations very high. I feel like haptics, while very sophisticated, is something new and exciting for our brains to interact with in the space. Am I tracking this correctly?
I think that's very true. Yeah. I think our current day devices, what we're familiar with in terms of haptics is vibration. So everyone already has a haptic device. Our phones vibrate with notifications, um, or all different sort of vibrations meaning different, I guess, types of notifications. And that is haptics. That's sort of where the commercial end of haptics stops. It's same with in VR, AR. I'll abbreviate to XR, extended reality, which kind of means just both. But in XR, we're used to having controllers, and these controllers vibrate as well. And so we're really used to vibration technology kind of being the standard for haptics. But that's why my field exists. And there's quite a few researchers in my field all around the world. And we're looking into taking that next step. Like, what is that next step going to be? Because we know, like, vibration doesn't represent basically any of the feelings that we get in our everyday. And so as we're pushing XR to become this more immersive, realistic thing, we can't stick with vibration just because that's not realistic. That's not something we feel often. It can't represent a whole variety of different sensations that we normally get. And so my field is sort of pushing towards like, what is that next step? What is that next step that'll elevate our immersion? There's so many different methods and body parts and areas that we can like work with. And that's what sort of we're researching.
Let's walk through some of those. Give me some tangible examples of things that you've worked on, and then we'll sort of come at it from a broader perspective of what the human body can deliver to us in a haptic sense. Let's talk about some of the inventions and the research that you're doing.
So really the focus of my thesis is not one specific actuation method or application or body part, but really what I'm looking at is practical and immersive haptics. And so my work has a bit more of a consumer focus because I sort of weigh the objectives of practicality and immersion equally. If you imagine something like if you're using haptics for medical training, you want something that's incredibly immersive and realistic, and you don't really care as much if it's impractical, if it's bulky and expensive, because that's something that would value sort of as much immersion as possible. Because otherwise, how are you going to have a good medical training simulator? And so I'm more in the middle where I want devices that maybe the everyday consumer could use. And that's why we need to think about things like practicality. Like, is it ergonomic? Is it uh, not bulky or not too heavy to carry around? Is it able to be built in a manner that is low cost enough that it's actually affordable for users? So those are sort of common practicality aspects. And then on the other hand, we still want it to be immersive enough that it's interesting. And one of the lens that I view immersion through is this idea of the sensory motor system. And so our body, our skin experiences sensations differently. You can probably guess what our most sensitive body parts are: our hands and our fingertips, which is the main way that we sort of touch the world. And so we have a ton of mechanoreceptors here that experience different sensations and they're very sensitive. But if you get to even like your forearm skin or your bicep skin, like all that skin is far less sensitive. It's much less dense with mechanoreceptors, and there's just like less of them, and they're less dense overall. And so these don't experience sensations the same. And so when we're thinking of building a haptic device, we don't need the same fine grained, high resolution device for our fingertips that we would need for our sleeves because our skin experiences things differently. And so when I think of immersion, I think of aligning it with our sensory motor system. And we only need to make each sort of body part's immersivity equivalent to what that body part can even experience. And that allows us to cut some corners because we don't need absolutely high resolution, super fine grain haptics everywhere on the body.
I want to ask about, I read one of your research papers, and there's a very tangible example of this. And I watched a video that was embedded within that paper, and it was involving the lips, and specifically the game that was created to demonstrate how a haptic system that interacts with human lips can really um, enrich the gaming experience. Can you explain to folks what that the research that you did and what we learned about the human mouth?
So this is very related because one of the research questions that started that paper was, what is the second most sensitive part of our body? Like everyone is making haptic gloves because that's the most sensitive. What's the second most? And it turns out that that's the mouth. The mouth area, the lips, that is the second most sensitive part of our body. And so we were like, why don't we try making a haptic device that is capable of actuating the lips? And there's some constraints there because one of the big things is we don't want a device that touches your mouth because that's unsanitary, it's unhygienic. You wouldn't be able to put that on a bunch of different people. So we were looking specifically for a non-contact haptic method. And so we came up with the idea of doing mouth haptics using an ultrasound phased array. And just a very brief sort of overview of how that works is that we have a bunch of ultrasound speakers. They all emit ultrasound at different sort of times, latencies, so that they all arrive at one point in space at the same time. And then the ultrasound waves will constructively interfere and build up enough acoustic pressure that it can actually vibrate that one node in space. And so it is using sound to create enough pressure in the air to vibrate the air, and then you can feel that vibrating air. And it's a very, very small point because ultrasound, the wavelength is only 8 millimeters. And so this node that you're vibrating is like around 4 millimeters. And so it's a very small point, but that's perfect because our mouth doesn't have a lot of surface area. So now we can create this tiny 4 millimeter dot and we can create a bunch of them and we can move them all over the mouth. And so we can do sensations like I think our most popular where you can drink from a water fountain and you can kind of feel like that sort of a bunch of like drops on your lips as if you're drinking from one of those water fountains. That one's my favorite. One that we did because horror games are very popular in VR is we made a whole scene in a haunted forest. And one of the things that would happen there is like a spider can jump on your mouth and like run around. And that got a lot of like visceral reaction out of people. And that's very fun. And like I said, I mean, I always check with people first, like, are you okay with spiders? Because some people, that would freak them out too much. But for most people, it's very fun. They end up laughing because they're like, oh my gosh, like they didn't expect to feel a spider on their mouth. And and then yeah, we had like I think 12 different interactions. There's much more that could be built. That was sort of just like a sample set. Um, and that's the device we built.
The moment when you tried that on and you either realized that it worked on yourself or you saw there has to be sort of a person zero who puts the device on and says, this is working. What was that moment like? Was it for you yourself when you tried it on, or did you observe it in someone else? Talk me through that moment.
Yeah, it was I tried it on. I sort of built the whole thing over the summer, like by myself. And one thing is that before I started the project, I had not personally used ultrasound phased arrays before. I'd heard of them, I'd watched videos on them, but with haptics, that's one of the issues is that I can write these papers and I can make these videos, but at the end of the day, it's impossible to imagine what it feels like. And that's why I always want like people to come to my lab and try the demos, then you can really get a sense of like what we're doing here. I had read about them, I had seen videos of them, I hadn't felt them. And so the very first time I built it, obviously as when you build any system, it didn't really work for a while. There's a bunch of bugs, I had to fix those. And the first time, like I felt a little bit and I was like maybe it's working, maybe not. And then I debugged more and finally when I turned it on and I felt it, I was like, wow, that it feels crazy. Like it doesn't really feel like a vibration, even though I just said it's a vibrating note in air. It feels like there's like a something there that's actually like poking into your skin, but it's not. It's air. It's air. We're moving you with sound. We're making you feel something with sound. And so yeah, it was really fun. I'd also like not necessarily when we were coming up with the demo apps, it was very funny because we were like, obviously all of our whole body feels a lot of sensations all the time, every day. That's what living life is. And so we're trying to think of like what are some really salient ways, things that we feel in our mouths. And my first thought really was the water fountain. And so I'm glad that one really worked out because I was like, I mean, that's the one where like I feel like that's something I feel in my mouth when I use the water fountain all the time. Or we're thinking like wind, rain, something brushing into your mouth. We have like you can drink things because we can also actuate sort of your teeth and tongue as well. But like you can drink things, you can brush your teeth. Like we're like there's so many mouth interactions, and having to sit down and think of all of them and like come up with like a fun list of them was a very interesting exercise. But yeah, feeling it for the first time was amazing. And it is a sad thing about haptics that until you feel it, you can never fully understand what the haptics is.
There's a magic that happens there between what you have scientifically designed and the shortcut and shorthand that our brain takes to make that experience match what our eyes are taking in. It really is a mix of like scientific alchemy in the coolest possible way. How do you view the idea of full immersion? When we talk about it in sort of the layperson's terms, we think about things that are already out there in the market. But realistically, I get the sense that you're talking about a different experience maybe than what we already think about, which is primarily a visual one. Maybe we're talking about the ability to walk and move in space. How do you view this?
I think one thing our body is really good at, like you said, is synthesizing our senses. And that is really, really helpful for haptics researchers. There is actually an entire subfield of the haptics community that looks into this sort of, it's called visio-haptic matching, but there's also visio-haptic illusions. So being able to make users feel like they felt something or feel like they felt something different than what they actually felt just using visuals. And so I actually don't do really work in that area, but it's a very interesting and important area to experience. And of course, I read the papers from that area because it helps me inform my design of experiences. Um, but it's really amazing how incredible our brains is. I think overall, one thing that doing research in haptics had made me appreciate is that like us as humans are so perceptive but also so creative in that our brain is so good at infilling, like if the graphics aren't perfect or the haptics aren't perfect or the audio isn't perfect, our brain is so good at infilling that it's still a magical experience even if like not everything's like 100%, and that's really nice. And so it is something like I end up facing even just like not from a research standpoint, but casually in my research, in that when I'm doing those final steps of finishing the demos before I sort of show them to users, it becomes a lot of like, well, that felt good, but the visuals, like if I just like tweaked it to be a little brighter and a little more to the right, I think that'll feel more accurate. And then now with this visual, I really like it. but then I need to like change the haptic parameters a little bit to match that a little better. And so we can tweak both sides until we get this really sort of immersive, magical experience. Um, but neither side has to be like perfect because we have this sort of like all of our senses working together to try to give you a great experience.
We've described it very effectively in terms of gaming when we talk about walking, in a horror game, walking through spider webs, drinking water, interacting with the game. Do you view the ability to potentially take something like this to a gaming market as then being a driver to actually even, you mentioned medicine at the beginning. It's a chicken and egg question is really what I'm asking. What do you think comes first in this capacity?
I'm a big believer in VR AR, hopefully, given how much I work in this field. But I think that the way that it's been marketed has actually, in my opinion, missed the mark a little bit. And what I mean by that is that, first off, as a gaming platform, it is a really, really fun gaming platform. You can get a VR headset for about the same price as like a Switch, and the games. There's not a lot of them because it's such a newer technology. You can't just port old games onto the VR headset. You need to fully redevelop them. But they're really fun. The games that they have are really fun. And so there is like a subset of VR that I think would be great just for gaming. But I think what VR can be really valuable for is actually more of an education tool. And I think that it hasn't been marketed enough in that direction. I think sort of I mean, we all kind of know that the main VR headset maker, I guess, is Meta. And I think they've been pushing more this idea of the metaverse, which is sort of an area, a place where you can live a second reality, live your life, but in the metaverse. I disagree with that. I think a lot of people do, but maybe some people don't. I'd be curious to talk to people who believe in that vision. But in my mind, VR is so, so good for education. And if you think about something like if you're teaching a classroom of students about history, and it's a very similar thing where like people, this has been proven time again in education research, was that people learn better when they're able to like interact with stuff. Like just some people are visual learners and some people are audio learners, but overall a lot of people learn really well when they're able to interact with stuff and feel things and like be immersed in things. And so if you imagine if you're learning about like the Silk Road, and instead of just like reading about it from a textbook and like having sort of like pictures on the textbook, I know personally that is somewhat difficult for me. But if you could put on a VR headset and like literally be in the Silk Road and like feeling the wares and like hearing the busy market pace, and like you turn around and it's like one of the stops on the Silk Road, um, I think that's an incredible way to like teach history. And you can think about this for like biology too. Like we hear about these deep sea creatures. I always loved learning about like ocean creatures when I was younger, and it would have been so cool to be able to put on a VR headset and see what sort of sea life is there, and like lower myself down into the ocean without having to physically do that, and see the different levels of like what sort of sea creatures exist at each pressure level. And so this sort of immersion can be such a good way of learning about all these different sort of subjects. And I think that's something that I find very interesting. It's also like you can do it for higher level. VR, AR, and haptics can be used for higher level, more for adult learning too. Like, for example, like I said, medical surgical simulations. If we can have something that's incredibly realistic for people to practice surgery on, or if you think about like pilot training simulation, if you can have a really, really realistic pilot training simulator between VR and haptics, because you can't have it be really realistic without feeling the haptics of like the controls or the weight on your body when you're flying. Um, if we can have something like that, that could be a really awesome tool as well for teaching. And so I think VR is such an incredible tool, but we need it to be more immersive and realistic in order to achieve the goal of having it be a tool. Um, and so in my work, I don't really focus as much on application area. Really, my work focuses on the device itself and the actuation method. Um, and so I don't tend to like work as much as like pushing this device for this sort of field. But I do think there's like a ton of value in that. And I think that is like a really important aspect of haptics is where it's going towards, and VR and AR.
I think it's a great conversation to have because it helps outline the most high altitude view. Speaking of putting on a headset and traveling as high or as far underwater as you want to see a big vision of what this all looks like. For you, then, as you're specifically talking about devices, one of the things that is ubiquitous in our lives, obviously, are our phones,
Mhm.
and we call them the second screen. I want to talk a little bit about the way we interact with screens and some of the work that you're doing that might help inform us in the future. When we think of our phones, a ubiquitous device, we interact with it in sort of a almost like a two-dimensional capacity. But I think some of the work you're doing offers maybe an expanded view of that. Tell me a little bit about what our hands can deliver in this haptic space.
Yeah. And so this also relates to I actually didn't do haptics before I guess this PhD. I worked more on the sensing and input side of things, which you need both. If you want to have a system, you want the system to have input and output. And really, I would love to be working on like closed loop systems. And so I have research that's also on the input side. And some of what we look at, especially in my lab mates are doing this as well, is looking at intuitive interactions with systems. And so, for example, I have a paper called Pull Gestures. And one thing that we're looking at there is that at the time, it was this new idea of foldable phones, which now have been around for a few years. But I'd still say is like pretty novel technology. I don't know a ton of people who have these foldable phones, but more and more foldable phones are coming out. And same with some companies have been releasing foldable laptops. That's really new. I only know of like a couple of models, and I honestly don't even know if they're still being sold. The idea of having two screens. And so when we're thinking about having two screens, how are we going to interact with something with two screens? One thing that researchers have discovered and that we've known for a while is that people really like a tactile keyboard. That's why in VR, when you're typing in midair and you're getting no haptic feedback, or you're typing on an iPad, people do not like typing like that. They like having the like tactile feedback of feeling the button press down and they know they've typed that. And I can't, and that is like something that has been studied. And so when we were thinking about like when we have two screens, obviously a very obvious solution for that is to just have a keyboard and like sort of project it on the bottom screen when you need to type. But we were also thinking of like how can we have more intuitive interactions with these devices that don't rely on sort of these form factors that people have already gotten into their heads that are like the typical form factors. And one thing we we're thinking is like it should be more along the lines of VR and AR, even though they're screen based technologies, of allowing you to sort of interact with them the way that we interact with our real world. And so, if you think about it, we sort of have this distinct way of interacting with devices. That is not how we interact with our everyday objects. Like, we have these buttons, and how often do you really push a button in real life? Like, if I'm grabbing things, like I'm grabbing my water bottle, I'm grabbing my mug, there's no buttons to press and something to click or something to scroll. You just grab. And so in this work, what we were like, well, we should just have this be like, you should be able to just grab things from your screen and like move them elsewhere or like, open your file by like how you'd open like you can open a folder like how you open a real life cabinet by just pulling it out. And so we're looking at these sort of intuitive interactions and it does become sort of like augmented reality because we're trying to bring our devices closer to reality, how we interact with things in reality. I think overall, this is a really important problem to solve because with phones, sort of one of my takes on this is that I think phones are super unnatural. It's basically like a small brick that we carry around all day, and we're always just kind of staring into this brick. And it's a very useful brick, it's a very informative brick, but it's a form factor that doesn't really make sense. Like it doesn't integrate with our body well. When I'm wearing something that doesn't have pockets, I always like to this day struggle with what do I do with my phone? I don't really carry a purse. And so I just end up holding my phone and I just have a whole hand that I can't use because I'm holding my phone. And so it seems crazy unintuitive to me, this device that we have. And I think looking in the future, I'd love for more integrated devices like AR headsets, I think could be one of the solutions to that. Not the form factors we have today, like the Vision Pro, which is really heavy and bulky and difficult to wear, but more like the Meta Orion, which is something they announced a few months ago, which looks more like glasses. And as we keep going, as we keep doing research, we'll get better and better form factors and it can be something that like is actually wearable that like blends into your like outfit and your ecosystem and that you can interact with these intuitive gestures like being able to just like grab things like we do in real life objects and like move them around, like being able to use like micro gestures or hand gestures. A paper I didn't work on but that came out of my lab is being able to point at stuff and just talk. which is a really intuitive thing we do with each other. Like if I'm walking with you down the street, I'll be like, look at that sign. But you can't do that with your device. And so my lab mates actually put that functionality into your phone where you could hold your phone up. And again, it would be more intuitive if it was like glasses or something. But since we have phones, you hold your phone up and you point and you go, what is that? And your phone will figure out what you're pointing at and answer that question. And so my whole lab, we really try to look at this like, how can we interact with our devices more intuitively and also push those devices to be more intuitive form factors.
That's absolutely fascinating and something that I think a lot of us can relate to. You talked about an improvement in form factors. What do you think needs to happen then, technically or socially, to be able to achieve an adoption of haptics that is as common as, our touch screens or voice for that matter?
I would actually say research haptics is not super compatible with our current devices like computers and phones, which are sort of standalone flat things. Um, I think haptics is really well paired with, well, first off, you can do haptics without devices at all. Um, Haptic feedback for like teleoperation, for example, I think is a really awesome thing that people are doing research into that is very applicable right now. Like if you're controlling like manufacturing robot and you don't want to be too close to it for safety reasons. So if you're like standing on an upper floor trying to control the robot, doing it just visually is really difficult because like if you're trying to grab a package, for example, and you don't know whether the robot arm has actually grabbed that package, that's really hard. And so you can use embedding haptics into that, like having a haptic glove where you can control the robot, and when you grab the package, you actually feel like you're grabbing something with your haptic glove. That's an example of a really important haptics technology that's not really tied with a or like it's tied with real life visuals, but not a visual device like your computer or VR headset. But in terms of, I guess, haptics for devices like our computers, phones, or XR, I would say that right now I think a lot of haptics is more tailored to the future in which AR sort of replaces our phones. So I would say a big block is sort of the technology to create AR VR headsets themselves. Part of that is like getting enough processing power in a small enough form factor. Um, getting enough battery life in a small enough form factor that you don't have to charge it every couple hours. Um, so I think I don't know enough about that because I don't work on headsets, I guess. So I do think there's a big bottleneck there, and it is a little bit chicken and egg where one of them like they're sort of both sides are getting better, but like haptics needs the headsets to get better in order for them to develop better haptics for the headsets, but the headsets needs haptics to get better in order to like understand, like, I guess, have users push towards having headsets being developed better. So both sides are kind of growing simultaneously and also sort of relying on each other, I would say.
I want to talk about moving floors because it's something that's a hot button item in the space is that because people want, I know we keep coming back to headsets, but it is relevant to some of the work that you're doing both in gloves as well as in a haptic environment for your lips, this idea of being able to move in a 3D space as well. And one of the things, it's very cost prohibitive. Where are you at in your work towards thinking about that?
My first couple of haptics projects have all been focused on more tactile sensations, which are like small scale forces, being able to feel like textures, and like the object surfaces, contact surfaces, that kind of stuff. Right now, I'm focused a bit more on the other side of it. There's sort of two pillars of haptics that people commonly refer to, one side being tactile, the other side being kinesthetic, and that means large scale forces. And underneath that category is also proprioception, which is sort of internal forces that we feel when we do things like balance or walk. That's all considered haptics because without a sense of touch, you wouldn't really be able to balance or walk because that's all your own muscles feeling each other, and then because of that being able to keep you upright. And so right now I just sort of completed the first round of my project on building an exosuit, which is a suit that applies forces on your limbs. And so now you can do things like feel like walls, like you can feel a wall in front of you. You can pick up objects and feel the weight of those objects. You can feel impact forces. One of the demos I really like is you can kind of sit on a train and like feel it swaying, and the exosuit sort of like sways you with the train. So that's something I just sort of completed the first iteration on. And then something I'm actively working on is proprioception, again, under the same category of sort of forces, big forces, but I'm working on an endless walking floor because I've found myself, I have a headset. I only use it for gaming, but it is, like I said, a good gaming platform. But even then, I find myself feeling really limited because I don't really have like a wide open space in my home where I can set up a whole area for playing a video game in. But then when I'm in VR, if I'm only standing in one place and I'm moving with a joystick, it like kind of makes it way less fun or interesting. Even me as a very casual VR user, I like feel like I would like a solution where I could kind of walk forever. And so, and there are a lot of people who use VR way more than I do. And so I'm sure this comes up for them too. And so I am currently working on a project where it's a floor that you can hopefully walk any direction on, so it's omnidirectional, and walk forever on, so it's always recentering you. And we've sort of went through a bunch of different ways of doing this, and so we don't have a finalized form factor yet, but that is a problem area that I am working on.
Vivian, let me ask you finally, what's the coolest part about your job and the research and the work that you're doing?
I really love working on devices for people. I would say haptics is a little bit more blue sky, like it's a little more 5, 10 years in the future. I don't think maybe longer, 10, 20 years in the future. I'm really bad at estimating, especially these days with technology improving so rapidly. But I just like it's so wonderful to me to see how people react to devices and feel happy about them, I guess. One of the reason I got a PhD is because I was lucky enough to do an internship at Disney Research when I was an undergrad. I was not planning on going to grad school. I was planning on just getting a job, but I worked at Disney Research because I grew up in California. I love Disney. And it was really amazing seeing those engineers there. They're these incredibly smart people and so innovative and so good at building robots and systems. And they were working towards building things that make people happy. Like that is the goal because Disney is not a tech company. Overall, their money comes from the entertainment industry, the movies. So all these like theme park robots and like interactive systems, that's not what's making them money. And so the goal of those systems for those engineers was how can we make the most people laugh and the biggest laughs and the biggest smiles, and that was their metric, was just like how happy do these devices make people. And that was incredible seeing that. I'd never worked in a company that does something like that. It really was like they would build something and they'd be like, all right, time for like the smile test, let's get 30 new people in here and like see how much they smile and how many of them smile. Um, and just like, do they get good vibes from this? And I really love that. And so from then on, I applied to PhD purely because of that internship. It was just like during the internship, I was like, all right, I'm going to apply. And then because they all had PhDs and they encouraged me to do it. And then I was like, I want to work on a system that humans can interact with. And it's a little selfish because there's a lot of systems that humans don't interact with that are incredibly important, like incredibly important work that improves the lives of everyone, even though people aren't physically interacting with them. But selfishly, I was like, I love seeing people smile and just like the things I build, and so that really drew me to where I am today.
I think your lab must be one of the most interesting and fun places on campus. Vivian, thank you so much for taking the time to talk to me today.
Yes, thank you so much for having me. It's been really wonderful to be here.
Everyone, you've been listening to Does Compute, the podcast where we examine how computer science is building useful and fun stuff that works. Thank you so much for joining us. I'm Steph Strickland with GeekWire Studios.